Hello students, now we are going to discuss important calculation numericals, that how to calculate enthalpy change of a reaction in terms of enthalpy of formation and in terms of bond enthalpy. How can we calculate the enthalpy change? The first problem is like this. The problem is like this. Methane when bonds in presence of oxygen forming carbon dioxide and water. If you balance it, here multiply 2, then here multiply 2. You see now it is a balanced equation. Okay? So it is called combustion reaction of methane. Question is, what is the enthalpy combustion? What is the enthalpy of combustion? Sorry. What is the enthalpy of combustion of this reaction? Enthalpy of combustion of methane we calculate. Given, what is the given? Given what? Enthalpy of formation of methane given, and enthalpy of formation of carbon dioxide given, enthalpy of formation of water given. How much? Enthalpy of formation of methane is, that is, the enthalpy formation of methane is minus 74.8 kilojoule, and for carbon dioxide is 393.5 kilojoule, and for water is how much? Minus 286 kilojoule. So this is the enthalpy of formation of individual reactant and products given. Then what is the enthalpy of combustion? Enthalpy of combustion, here what happens? We know for any change, as it is a enthalpy of combustion reaction, so enthalpy change for the reaction in the form of here what? Combustion, because reaction is combustion, is summation of enthalpy change of product minus enthalpy change of reactant. This is a very important formula to know the enthalpy change of the reaction if the reactant or product are given. So enthalpy formation of product, enthalpy formation of reactant. Here what happens? What are the enthalpy formation of product? Product is CO2 and water. So how many CO2? One CO2. One CO2 is how much? This much, minus 393.5. Then minus here how many? Plus. Plus here water is how much? Minus. So 2 into 286 kilojoule. Okay, this is for product, minus how much? Reactant. Here reactant is only CH4. Here enthalpy of CH2 is minus 74.8. Okay. Then this kilojoule. Here as 1 methane, this much, plus 0. Because enthalpy formation of element is considered 0. In standard state is considered 0. So result will be, if you calculate this one, now you calculate it, how much result is coming. This is 2 minus sign and this is result is plus. So minus 393.5 minus is minus that Okay, kilojoule. This value minus minus plus 74.8 kilojoule. Okay, so what is the answer is coming? How much? The result is minus. How much? You calculate. Result is minus 890 kilojoule. This is the enthalpy of combustion. Only one formula, remember. Enthalpy change for any reaction is equal to product enthalpy formation minus reactant enthalpy formation. You have to add for both sides, then product minus reactant you have to do. This is a very important technique to calculate enthalpy change of any reaction in terms of enthalpy formation. Okay, this is the problem 1. Then problem 2. The problem 2 is like this. The reaction given 2H2 2H2O2 changes to water plus oxygen. Here it is a liquid, water also liquid, oxygen is gas. Here balance, you multiply 2 here. Now it is balanced. This type of reaction is given. What are the data given? Enthalpy of formation given. Given data is important. Here enthalpy of formation of H2O2 is given. Then enthalpy of formation of water also given. How much? For enthalpy of formation H2 is minus 100 minus 188.0 kilojoule. And for water is already have the minus 286 kilojoule. Okay. So enthalpy formation of H2O2 water is given. But what is the question? How much? Question is calculate internal energy change. Question is calculate internal energy change. Okay. At this condition means standard state. Enthalpy formation is given in standard state. At, you can say, at 25 degrees Celsius. So, to calculate internal energy change, you have to know the enthalpy change. So, what is the enthalpy change for the reaction? Enthalpy change is that like this. That enthalpy change for this reaction, enthalpy change is equal to how much? Here, that product minus reactant. Here product is 2 into what is the enthalpy formation of water? 2 into minus 286 minus, then here this is 0, then minus 2 into how much? That is minus 180 kilojoule. Okay. So how much result you calculate? This is your how much? 2 7 5 minus this much, minus here plus 6 7 3 plus 3 kilojoule. Okay. So how much result enthalpy change for this reaction? How much? Result is minus how much? Here result is minus 196. Here minus 196 kilojoule. Here result is minus 196. Enthalpy change is calculated. But question is internal change. We know enthalpy change is equal to internal changes plus del N RT. This is del N RT G. This is del N RT G. And how much result? So enthalpy change is minus 196. Del is asked plus what is the value of del N? Del N means product minus reactant gaseous difference. Here gas is only oxygen, here liquid. So 1 minus 0. So that is 1. Del N is 1. Into here del N is equal to 1. So R value is 8.314. Because as it is given in kilojoule, so by 1000 you have to divide. So this because 8.314 in joule. So kilojoule means you have to divide into 1000. okay, into R into T. Here T is 290. So del U is equal to, it will be come to this side. Okay. So what is the answer? You calculate. What will be the answer? Answer will be, you have to calculate this one. That much here minus 198 kilojoules. This is the internal energy change. This is the, when you are calculating last answer, you should write in a box. This is your answer. This is your answer. So that examiner will only, he will check whether your answer is correct, but your answer should be in value with unit. That is very important. Without unit, you will lose half mark. With for wrong answer also you lose half mark or 1 mark. It depends upon the marking scheme. So, but answer should be value with unit, and the last answer should be written in box. So this is the what? Second problem. Then third problem is like this. Problem third. What is the third problem? The problem is enthalpy of formation is given. Enthalpy of formation of methane is given. How much? Enthalpy of formation methane is minus 70.8 kilojoule. And enthalpy of sublimation of carbon. Sublimation of carbon means carbon is converted to gas. Sublimation of carbon is plus 719.6. Okay. And enthalpy of dissociation of hydrogen. Enthalpy of dissociation of hydrogen is how much given? 4 plus 435.4 kilojoule. This is the data given. But question is calculate bond enthalpy of CH bond of methane. This is the question mark. From this data we will calculate the bond enthalpy, that is CH bond enthalpy of methane. You see, for this type of question, you have to see the expression. Enthalpy of formation methane. Enthalpy of formation is CS plus 2H2G convert to CH4. So this is the data. That is how much? Delta H is equal to how much? Minus 74.8. This is the data. Then enthalpy of sublimation of carbon, that means CS convert to Cg. Here enthalpy change is how much? Delta H is equal to how much? That is 790.6. Then dissociation enthalpy of hydrogen, that means H to G convert to 2HG. For this change, here how much? Delta H is equal to how much? 435.4. 435.4. Okay. Then what will the question is? This three value. This is the equation 1, equation 2, equation 3. Three equations given. From this three equation, how can we get the what? Formation of methane. Here formation of methane given, everything given. How can we get the expression you see? Dekho. We want formation, you can write like this here, CH4 and H2 convert to 2H. So if you write this one, okay, so just you write here equation 2 minus here plus. Okay, that means what you will do? Equation, just to check, equation B plus C minus A. This is the expression B plus C minus A, because so that we will get the value of methane. So here what happens, minus minus plus means CH4 will be the left side. Better one thing you do, okay, just minus, okay. Equation, this equation minus means it will come to, my CH4 will come to left side. So CH4G. Okay, then this minus cancel. Then what is left? 2H2 and H2. How much left? How much? 2H2. Then 2H2 here. 2H2 minus 2H2. And here is how much? H2. Result is H2 will be that side. Here H2 will be. Here left side will be CG. Okay, CG, H2G. Okay, then 2H2G. Here 2H will be added and minus, that will be how much? 4H. Now become 4H, convert to 4H. You see 2H here. And here what happens? 2H2 will be this side, 2H minus 2H2 and here H2, remaining 2H2, H2 and 2H become 4H. So you can write 4H. So this reaction result will be how much enthalpy change? For this reaction how much enthalpy change? For this reaction here you see it will be added and all will be added. Result will be 1665. 16 is 5.2. 1665.2 kilojoule. 1665.2 kilojoule. This is for what? For the breaking of CH4 bond to C and 4H. Then if the CH4 is broken down to convert 1 carbon 4 hydrogen, that means it is the dissociation enthalpy. The dissociation enthalpy of CH4 is this much. Then how much? What is the bond enthalpy? CH bond, as methane has 4 CH bond, 1 CH bond will be 16 by 16.2 by 4. So result will be how much? 416.3 kilojoule. So this is the what? Bond enthalpy, CH bond enthalpy of methane. So from the data we have to think what we have to calculate. As this is the data given, formation of methane, formation bond, sublimation of carbon and dissociation of hydrogen. So we have to convert methane into dissociation form. From this reaction, which equation we have to add, which equation we have to subtract, you have to think. As methane in the right side, it will have to give the left side. So if you minus, then minus will left to become plus. So methane is coming. Here you see CS is cancelled, minus plus cancelled, 2H2 minus 2H2 and H2. So minus 2H2 remain, minus H2, right side 2H. Automatically it is 2H2 or 4H, you can write like this. So result is, but this is the enthalpy change. But CH4 break down to C plus 4H. So what is the, here what happens? 4 hydrogen break. So 4 hydrogen is removed from the CH4, energy change this much. For 1 CH bond is 1664 by 4. That is average. So this is the bond enthalpy, CH bond enthalpy of methane. In this area you can also calculate. Next is, we will calculate now neutralization. Okay, you write down this one. Problem 4. Problem 4 is like this. Reaction is like this. NaOH reacts with H2SO4 forming sodium sulfate plus 2H2O. We multiply this is the reaction. Okay, and then 2SO4, 2H2O. It is balanced. Okay. So here question is, here how much given? One is base, this is your acid, so it is a neutralization reaction. But what is the concentration of NaOH given? That 500 ml of 2m NaOH mixed with, this is the question, this much of volume of solution of NaOH having strength is 2m NaOH or concentration is 2m NaOH mixed with same 500 ml of 1m, let it be 1m sulfuric acid solution mixed. This one mixed with this one. So question is how much heat change takes place. That means how much of heat is produced. This is the question. We have to apply the enthalpy of a neutralization reaction. Enthalpy change in terms of a neutralization. Just you see, 500 ml 2m NaOH contain how many OH minus? We know the formula. M is equal to N into what? N into 1m, capital M is equal to N into V into 1000. This is for what? NaOH. This is for NaOH. Similarly for, let it be for sulfuric acid, M of sulfuric acid formula will be N into V into 1000. This is the formula already you have read in first chapter, normality and molarity formula. Here question is in terms of molarity we are calculating. Here N is as per the question given 2. So 2 is equal to, N is not given, V is 500, V given 500. Okay, is V is 500, then what is the number of moles we are calculating? 500 and here V into 1000. What is the result? What is the value of N here? N means OH minus, number of OH minus, NaOH means OH, number of moles of OH minus is equal to, sorry, you write number of NaOH. Number of mole of NaOH is equal to how much? So 500 2000 by 100, that means N is equal to 1. So number of moles of NaOH is 1 is coming. For you see this reaction. Here what happens? M is 1, N you will calculate N, V is 500, then volume is 1000. So what is the value of N? So N is equal to 0.5 mole. Here N is what? Sulfuric acid. Just you see, now you calculate what number of moles of NaOH present in the solution. Here number of moles of sulfuric acid present in the solution using that molarity formula. Molarity is equal to number of moles in volume of solution 1000. This formula will be used here. Then what is then if number of moles of NaOH is 1, then number of moles of OH minus is how much? It will be 1, because 1 NaOH produces 1 mole OH minus. But here number of moles of H plus is how much? If 1 mole sulfuric acid is 1 molecule of sulfuric acid produces how much? 2H plus. So 0.5 mole produces how many H plus? Twice. That is 0.5 into 2. That is what? 1 mole. That means here you see number of OH minus present in the solution is 1. number of H plus ion present in the solution is also 1. If both H plus and OH minus is same, then you multiply. Here, number of OH minus is equal to 1 mole, number of H plus also equal to 1 mole, because you have to calculate number of H plus, number of OH minus. We know 1 H plus, 1 mole H plus on react with 1 mole OH minus. Already you know the enthalpy neutralization produce how much? That is minus 57.1. That is minus 57.1 kilojoule is produced. This is the formula of neutralization reaction. If 1 H plus 1 mole H plus reacts with 1 mole OH minus, the enthalpy change is minus 51. As per the question, OH minus is 1 and H plus is 1. So this is the answer. Answer is, this is the enthalpy change. Enthalpy change of this neutralization reaction is minus 57.1. So there is a formula, remember. If number of, suppose N1 is equal to, suppose N1 is equal to H plus ion concentration and N2 is equal to OH minus ion concentration. After calculation, number of moles of H plus is N1, number of moles of N2 is OH minus. If, very important is, if N1 is greater than N2, if N1 is greater than N2, the lower factor, the smaller factor will be considered as per the limiting reactant. If N1 is greater than N2, here N1 is greater than N2 means which is lower? N2 is lower. So enthalpy change will be, that is the important formula, enthalpy change of neutralization reaction will be N2 into minus 57.1. This kilojoule. So you have to calculate the number of moles of acid, then number of H plus ion, then number of moles of base, then number of OH minus. Here in case of NaOH, 1 mole produce 1 OH minus, but in case of sulfuric acid, 1 mole produce 2 mole H plus, because sulfuric acid is H2SO4. 1 mole produce 2 H plus, so 2 is multiplied. So both case number of mole of OH minus H plus is same. That's why result is minus 57.1. So there is a formula. If N1 is H plus, if N1 number of moles of H plus, N2 is number of moles of OH minus. If N1 is greater than N2, then the enthalpy change will be smaller value will be considered. So N2 into minus 57.1. This thing is, remember, don't forget which is smaller. That value will be taken and multiplied with minus 57.1. That is the result of enthalpy change for this neutralization reaction. So you have to practice like this for all types of enthalpy change calculation, and any doubt you have, you can contact and we can interact with me. Okay, thank you all.